Alright guys, it's Mr. Spilker here. Hello and welcome to Chapter 12, Section 1, Operations with Radicals. In Chapter 12, Section 1, in Part 1 here, we really have two objectives. The first objective is to identify or estimate square roots, and we really did that in class today. So our main focus of this teaching video is the second objective, which is to define and write square roots in simplest radical form. So if I was doing notes here for this section, I would write 12.1, Part 1, Simplifying Radicals. Alright, we talked about the definition of a square root in class today, so I don't think there's a big need to go over the definition of a square root again, but I want to make two important points that are very, very important here for the entire chapter, and that is that the square root of a times the square root of a equals a. So think about this. The square root of 9 times the square root of 9 is actually equal to 9, because the square root of 9 is 3, and 3 times 3 is equal to 9. Does everybody understand that? So just always remember, when you're multiplying two square roots that have the same radicand, the answer is just that whole number. So square root of 9 times square root of 9 is equal to 9. The square root of 5 times the square root of 5 is equal to 5. Okay, that's a very important property. The other thing I want to mention is that a square root and a square are opposites. They cancel each other out. So if I took the square root of 8 and then squared it, guess what that would equal? 8. So the second important point I want to make is that a square root and a square cancel each other out. Alright, our glossary terms for today, I don't think there's a need to copy them all down. Once again, we talked about the definition of a square root in class today. That should already be covered. You may want to write down a principal square root. A principal square root is just the positive square root of a number. Alright, so anytime you see the radical sign, what we're talking about there is just the principal square root. So down below, it's important that you understand the square root of a indicates the principal square root, meaning the positive square root. Negative square root a indicates we want the negative of that square root. And then plus or minus indicates that both roots of a are needed. And it's read plus or minus the square root of a. I'm going to go ahead and do a couple examples of this on the next slide. Alright, you might be thinking, well, we already did this in class today, but the thing that's different about what we did in class today compared to this is just mixing in the signs. So we all know that the square root of 144 is just plain old 12. Negative square root of 64, well, that's going to be the negative root, so that's going to be negative 8. The square root of 23, obviously, that's just going to be a decimal that lies between 4 and 5. And since there's no sign out front, it's just going to be positive, that decimal. And then our last one here is plus or minus radical 49. So that would mean that we have two roots, plus or minus 7, positive 7 and negative 7. So just be careful of the sign out front and understand what that means in terms of the sign. Alright, here's the main part of the lesson, and that is simplifying radicals. A square root expression is in simplest radical form when all of the following conditions are met. Condition number 1, no factor of the radicand is a perfect square other than 1. Remember, what we mean by radicand is that number inside. So the square root of 8 would be what we call the radicand. Does everybody understand that? I'm running out of room there. But the number inside is the radicand. The radicand cannot have any factors that are perfect squares. The radicand cannot be a fraction. Okay? And no radical can appear in the denominator of a fraction. And we'll address that third rule later in the week. So those are the three main stipulations when you're simplifying a radical. Alright, let's jump right into simplifying radicals. We're going to start off with just numbers here, and then we'll work our way into adding some variables in. So simplify each radical, and they want you to do so by using the factor tree. That's going to be the easiest way. So the square root of 18. Well, if we made a factor tree for 18, 18 would be the same as 2 times 9, and then 9 would be the same as 3 times 3. So the square root of 18 is the same as 2 times 3 times 3. Now, if you have 2 of a factor inside the square root, that pair can come out as just a single digit, because remember, a square root cancels out a square. So 3 times 3 is the same as 3 squared, and the square root of 3 squared would just be plain old 3. So the square root of 2 times 3 is actually written as 3 radical 2. Let's do a second example. I'm going to jump down to number 3, the square root of 75. The square root of 75 could be written here as the square root of, and I'll do a factor tree of 75 off to the side. When I think of 75, I think of 3 times 25. And when I think of 25, I think of 5 times 5. So 75 would be 3 times 5 times 5. And 3 times 5 times 5 can be simplified because you have a pair of 5s. Anytime you have a pair of numbers inside a radical sign, that can be pulled out as just 1. Because remember, 5 times 5 would be 5 squared, and the square root of 5 squared, a square root and a square cancel each other out. So it'd be left with just plain old 5. So it'd be 5 radical 3. So those are 2 examples of simplifying square roots of numbers. Just remember, do the factor tree. Once you've done the factor tree, look at the factors you have inside the radical. If you have 2 of a factor, it can be pulled out as 1. Alright, the next thing we're going to do here in Chapter 12, Section 1 is go ahead and add in some variables. Now this is something that's new to us. Okay, we haven't really talked about simplifying square roots of variables. Because the radical sign designates the principal square root, the value of the square root of x squared must be positive. So you use the absolute value sign to indicate this when the exponent of a variable in the radical is even, and the simplified exponent outside the radical is odd. Now, just in general here, I mean, I understand that can be kind of a confusing definition there. Just keep in mind that this is just what we did. I mean, this is just the same as what we did with the factors with numbers there. Think about x squared. X squared, if I were to expand it out, would be x times x. How many x's do I have inside the radical? 2. And when you have a pair, they can come out and be just 1. So the square root of x squared is actually just plain old x. Okay, if we think about x to the third power, I'll switch over here to the left side of the screen. X to the third power would be x times x times x. So x to the third power, well, you have a pair of x's, so they can come out. So you'd have x radical x. So just remember with variables, if you have a pair inside the radical, they can then go ahead and come out as 1. It might be a good idea to write down some of these examples into your notes, so that way you can use it as a resource when you're working with variables. Alright, last slide here to finish up our notes for Chapter 12, Section 1, Simplifying Radicals. This is the whole lesson for today combined. Okay, if you're looking at these, you're seeing the radical of 72a cubed b to the fourth. So we got numbers, we got variables, we got everything. Once again, to simplify this radical, we want to go ahead and completely factor it. So on the side here, I'm going to do a factor tree for 72. Now when I think of 72, I think of 9 times 8. 9 can then be 3 and 3. 8 would be 2 and 4, and 4 would be 2 and 2. A good old factor tree, just like we practiced in class today. So if I were to expand this out, ladies and gentlemen, I would have 2 times 2 times 2 times 3 times 3. Then I'm going to have to expand this further because I got to get my variables in there. So I'd have A, B, 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 B. So that right there is the expansion of 72a cubed b to the fourth. Now, keep in mind, if you have a pair, I'm going to circle my pairs. If you have a pair, they get to come out of the radical. So coming out of the radical is going to be a 2. It's going to be a 3. It's going to be an A. It's going to be a B. And it's going to be a B. And then left inside, lonely inside, is the 2 and the A. Then I can go ahead and simplify those terms out front. 2 times 3 is 6. A and B times B is B squared. So my final answer is 6AB squared times 2A. That's example number 1. So in review, I factored it out, and then the pairs got pulled out front, and then I simplified it. Alright, one more example for today, and I'm going to choose example C. And example C is 98m cubed. So once again, we're going to start off with a factor tree of 98. Okay, when I think of 98, I think of 2 and 49. And then when I think of 49, I think of 7 and 7. So now I have my prime factorization there. So 98 is 2 times 7 times 7 times m times m times m. That's what it looks like when I expand it out. Now, if there's 2 of a factor, guess what I can do with that? Pull it out. So the 7's come out, the m comes out. Now, when the 7's come out, keep in mind they just come out as 1 7 because a square root and a square are opposites. They cancel each other. So I would have 7m, and then left inside would be radical 2m. So right there, I've simplified 98m cubed. 7m times radical 2m. Hopefully this information helps. Make sure you have these examples down. There's a few more examples in your book if you need to look at them. Come into class tomorrow, ready to go over Chapter 12, Section 1. At the beginning of class, we'll have another quick visual of this that'll help kind of reteach it and re-explain it a little bit. And have you ready to work on some of these simplifying radical problems, which will be our focus tomorrow. Thanks for watching. Have a good night.
Made with Doodlecast Pro.